Can make a list.
Y'all ready?
Quiz 1? Quiz 6? Oh, God.
All right, so today we're covering 2.1, and notice that 2.1 is on the test. So hopefully you spent the entire weekend getting all caught up on all this stuff, and so you're ready. Yeah? And so all you really have to do in the next 2 days is just make sure you understand 2.1. We'll see. I am going to, at the end of class, I'm going to pull up one of my old tests I gave, I think, 2 years ago. And I'm not going to show you the test, but I'm going to talk through the problems as far as like what the concepts were over, so that you have some idea of, a format of what you want to maybe focus on a little bit. All right? So that's the plan. So 2.1, the notes that I have for this section are very long. And so I was thinking about this before class. I mean, these notes start here. And I mean, this is all 2.1. And so what I'm going to do is I'm going to kind of shorten this up a little bit. Just get down to the important things, okay? Oh wait, that's 2.7. Sorry. There, that's where it ends. All right, so I thought I would start with just the picture of what we're trying to do, and I did this last class, but I did not bring up the notes. So everything that we're doing here is based upon this concept of a tangent line. Come on. So on a circle, if we have 2 points on a circle, right, then we have what's called the secant line. But if we move one of the 2 points over to where it just gets on top of the other one, then we have what's called the tangent line. So a tangent line is a line that passes through the circle at a single point. And what we're trying to do is do the same thing but on a function. So when we have a function like this, and we fix a point here, okay, so this is our point that we're going to fix. And then we have a second point. This would be called a secant line. And we could find the slope of the secant line by doing rise over run, which is y2 minus y1 over x2 minus x1. So if we had the 2 points, you could find the slope. I trust that you understand that part from college algebra? Yes? But visually what we're doing is we're pulling that second point over, getting it closer and closer to the other point until we get exactly on top. And let me zoom in. So we're going to move that right on top, and finally, once we get there, this will be our tangent line. Now, you have to be a little careful because on a circle, this tangent line only hits the circle in one point, right? But on this function, this line only hits the graph at one point here, but it might hit it like over here somewhere. That doesn't matter to us. It only matters what's happening locally. Does that make sense? Okay, so to do this, we're going to come up with a formula. And I started to do that last time. And we're going to use this formula to find the slope of the tangent line. So that's where I want to pick up today. I just want to draw out. Yeah, that's not the one. Yeah, okay. So I just want to draw out our scenario. We're going to derive the formula, and then we're just going to start using it. All right? So the formula for slope of tangent line of a function. So let's start with our picture. We have some function. We have to first pick some initial point that we're going to be talking about, which we'll just call that point A. And so what we'd like to do is find the slope of the tangent line here, right? So we have to now pick our second point, which I can call a plus h. And we did talk about that last time, the a plus h? Yes? Okay. And so that would be, you know, somewhere around here. The coordinates of these points, what is the x and y coordinate? Oh, by the way, this is the function f. Okay, this is the function f. So what are the coordinates of this point? This marker's not very good. What's the x coordinate? A. And the y coordinate is f of a. It's whatever the function's value is at a. We don't know what the function's value is, but if you plugged a into the function, you would know it, right? And then this point, the x coordinate is a plus h, and the y coordinate is f of a plus h. All right? So the slope, m, of the secant line is equal to y2 minus y1 over x2 minus x1. Yes? So y2 is f of a plus h minus y1, which is f of a, all over x2, which is a plus h, minus x1. What's x1? A. And then there's one more thing we can do to clean this up. In the denominator, we want to just simplify this. The a's will cancel and you just get h. Okay, so this is the slope of the secant line. Is that what we're interested in? It's not what we're interested in. Now in your homework there are a few problems where they do want you to calculate the slope of the secant line. So they say find the slope of the line, you know, between these 2 points. They give you 2 points and they want you to find the slope of the line. All right, so you do this. What we're interested in is moving that point, moving this point right here over towards A. So we want to slide that over. And to do that, what we're going to do is we're going to let that h get smaller. If h gets smaller, then this point will slide over. Do you understand that part? Because that's an important aspect of this. Like, why are we letting h go to 0? Because that means that what you're adding to a is getting smaller, which forces this x coordinate to slide over. Make sense? Okay. So the only difference between this formula and the formula for the slope of the tangent line is to take this and take a limit of this equation of this formula. So if we want to do the slope of the tangent line, we're going to just add the limit as h goes to 0 of that formula. I apologize, I've been fighting some allergies. I'm sure I'm not the only one. Okay, so this is the big one right here. That's the big formula for this section. That will give you the slope of the tangent line. Now, although this gives us the slope of the tangent line, it does not actually give us the equation of the tangent line. There's a difference, right? If I tell you the slope of a line is 3, you know the slope is pitched up, right? But you don't know where that line is. It just has a slope of 3. So another question we could ask ourselves is, what is the actual equation of that tangent line? So think about if we had the tangent line here, right, coming through here. If we had this line, then how could we come up with its equation? So go back to college algebra. What do you need in order to define a line? Like, what do you need for to come up with the equation of a line? What is it that you need? What's that? Well, you don't know anything about this line other than the fact that it has a slope, right? Like you would have its slope, but how do you find its actual equation? X and what do you mean? Okay. Okay, so let's just go way back to college algebra. Okay? If I have a line, right? What do I need in order to define a line specifically? Like just think about it abstractly. 2 points, right? You need 2 points to define a line? So if you were given 2 points back in college algebra, one of the things you would do is find the slope. right? You'd find the slope first, and then you would use this formula. There was a formula, it's called the point slope formula. Point slope formula. Remember this thing? This point slope formula. This is a formula for lines. And it goes like this. Y minus y1 equals m times x minus x1. Does that look familiar? When do you use this formula? When you have a point on the line and the slope of the line. When you have that information, you use this formula. And specifically, you just replace m with the slope that you have, and you replace x1 and y1 with the point that you have, right? So go back to this picture here, this red line. We can find the slope by doing this, right? So if I have the slope of that line, all I need now is a point. Do you have a point? What's the point on that line? AF of A, right? AF of A. So in that sense, let me erase this because we aren't really going to need the secant too much. If we want to find the equation of the tangent line at, let's go x equals a, okay? It will be this formula, okay? So watch what I'm going to do with this formula. Y minus, now what is y1 going to be for us? In this general picture, what's y1? That's this right here, right? That's f of a. So it's going to be y minus f of a equals, now m for us is this m, isn't it? So I'm going to put m tan, parentheses, x minus, and what's x1 for us? A. This is the second important formula. I mean, really, you don't need to memorize this formula, because if you know that formula and understand what's happening visually, you can just plug in your x1 and y1 from here. But do y'all get how this is going to work? Any questions on this? Sure? Okay. Let's do an example. What's going to be difficult in these problems is not the plugging in of the formula. It's the algebra required. That's what's going to make these tough. Challenging, I should say. All right, I'll leave that there for now. I might need to move that formula. All right, example. Find equation of line tangent to f of x equals 2x cubed minus 4x plus 1 at the point 1, negative 1. I'm going to move these. I'm just going to real quick write these over here. And then the other one was y minus f of a equals m tan x minus a. Okay, those are the two formulas we'll be using. All right, so at this point, do we know what anything is in our formula? Like, do we know anything from these formulas? Where are we trying to find the slope of the tangent line? Where? At 1. At x equals 1, right? So this right here is telling us the x-coordinate of the point that we're looking at. Now, does this point live on this graph? I did this real fast. So let's see. 1 goes in here. We get 2, and then minus 4. That's negative 2 plus 1. We get negative 1, right? So that point lives on that graph, right? And so there should be some tangent line on that graph, and we need to find the equation of it. So we know right now that this 1 is the a, right? And this negative 1 is f of a. Yes? So according to this formula, if we want the slope of the tangent line, we're going to take the limit as h goes to 0 of f of what? A plus h. But what's a? 1, right? So this is going to be 1 plus h minus f of a, which I'm going to write as f of 1. Is that okay? Now we know f of 1 is what? Negative 1, but let's just put f of 1 here right now. All of this over h. Okay, so I'm going to go ahead and grind out this limit, see what happens, and then at the end, when I'm done, whatever answer I get, that'll be right here, and then we'll just plug the other parts in. Understand? Okay. Let's just see what happens right now at this point. If h went to 0, okay, if h went to 0, right here, this guy right here, if that went away, you would have f of 1 minus f of 1, which would be 0. And on the bottom, if h went away and went to 0, then you would have 0 on the bottom. So you have 0 over 0. And that's bad, and so we need to do some algebra, right? So right now, we cannot do the limit. So we're going to continue. So I'm going to write the limit because I'm not ready to take the limit yet. And now I'm going to have to figure out what f of 1 plus h is. So that means I'm going to come back to my function, and I'm going to replace every x I see inside the function with 1 plus h, right? So I have to go 2 times 1 plus h cubed minus 4 times 1 plus h, and then plus 1. Right? This is what it means to plug 1 plus h into the function. That's what it means. What are some common mistakes that I see? I'll see students do this. 2x cubed minus 4x plus 1 plus h. That when you do f of 1 plus h, I'm sorry, they do this. In other words, they plug 1 into this, and then they just throw an h on the end. That's completely wrong, right? That is not what it means to plug 1 plus h into the function. This is what it means to plug 1 plus h in, right? Okay. Y'all look at me like, who would do that? But trust me, it happens. Okay, so that's this. Then I do minus f of 1. So minus, what is f of 1? Let's go ahead and replace it. That's negative 1, right? That's this right here. We already know that that point kicks out our f of a, which is really f of 1. We good? All right, all over h. Here we go. So we're going to need to do a little bit of algebra before we actually take a limit here. And the algebra that I'm going to need to do is I'm going to need to cube 1 plus h. That means I have to do 1 plus h times 1 plus h times 1 plus h. And I recommend that if you ever have to cube a binomial like that, if you don't already know what this is, because some people might just know what this is already, I recommend you put those two together first. So multiply those, then you have to do FOIL on those, right? So I'm going to trust that you could FOIL these two out. And if you got those, you would get 1 plus 2h plus h squared. That's what you would get if you multiply those two together. Then, to multiply these two together, what you do is you start with the first term, 1, and you multiply it through to all 3 terms. After you do that, you take the h and multiply it through to all 3 terms. So you're going to have a total of 6 multiplications to do here, right? 1 through and then h through. So let's see what we get. When we pass the 1 through, we get 1 plus 2h plus h squared. What happens when we pass the h through? Plus h plus 2h squared plus h cubed. And collect like terms together. H cubed plus, we should get 3h squareds.
3h, get 3h squared
Okay.
plus 3h.
Plus 3h plus 1.
Minus 1, so you cancel it out.
Oh, you mean up here?
Yeah.
Oh, that's going to be a minus though. Be careful.
Leave that in there.
Yeah. Okay, so this right here, look, this right here is just this, isn't it? That cubed, that's all that is. I still have a 2 in front of that. So my next line here, I'm done with my scratch work over there, is limit h goes to 0. I have 2 sitting in front of h cubed plus 3h squared plus 3h plus 1. Y'all following me? Okay, so that's just this. Minus, let's go ahead and distribute the negative 4 through. So minus 4, minus 4h, and then I have plus 1 from here, and then another plus 1 because it was minus minus. And then all of this over h. Now, this continues to simplify. You have to pass the 2 through now. So let's do that. I think I'll do that up here. All right, so we have limit. See, I'm still writing the limit. Every single time I'm writing the limit. 2h cubed plus 6h squared plus 6h plus 2 minus 4 minus 4h plus 1 plus 1. Now, yes, I could have put those together, but I'm just putting it all out there again. Okay, questions up to this point? Now, if there's any justice in the world, which there's not, this should clean up really, really well. So let's see what happens. Let's get rid of these constants. I have a 2, I'm taking away 4, but then I'm adding 2. So that should go away, right? Like that's like 4 minus 4, basically. And then otherwise, the only other thing I can do is I can put this 6h and take away 4h, and that gives me 2h's, right? So here's where I am now. I have in the numerator 2h cubed plus 6h squared plus 2h all over h. Now, right now, at this point, if you try and plug in h as 0, so if you try direct substitution, you're still going to get 0 over 0. However, the numerator, each term has an h, right? So you can factor a single factor of h out of the top. And that's going to be what gets us over the hill here. We pull that h out, we get 2h squared plus 6h plus 2, then all divided by h, and the h's cancel. One more line, and then I'm ready to take the limit. Limit, h goes to 0, and I have 2h squared plus 6h plus 2, right? And now at this point, if I let h go to 0, notice that this gets killed off, but I still have the 2, right? So my answer is 2. And that means the slope of the tangent line at that point is 2. Questions? Have I found the equation of the tangent line? I have not. So I've only done this part. And it required some algebra, but I got it. So now I'm ready to come in and find the equation of the tangent line. So for the equation, so I'll put over here, this is the slope of tangent line. I'm just going to say tan line. Now the equation of tangent line is going to be y minus f of a. What was f of a? Negative 1, right? So I'm going to have minus a negative 1 equals m. What was m? What was our m tan? Sorry. 2, and then x minus 1. So this is y plus 1 equals 2x minus 2. I distributed the 2 through. And I'm going to subtract 1 from both sides. And that way I get it into this form that we really like. Don't we like it when our lines look like this? Y equals mx plus b. Y'all good? So I made this problem up just now, right when I put it up there. So I'm going to see if we got it right. What I'm going to do is I'm going to get onto the computer. I'm going to graph this. I'm going to have a computer website graph this. Then I'm going to have it graph this. And what I should see is this line hitting this function at this point, and that line should look like it's tangent to the curve. Right? What do you think? Y'all feel good about it? Maybe I'm not going to. Let's see what happens here. You can do it. You can do it. All right, here we go. As far as conceptually, do you understand what you need to do here? Like what's going on? Okay. The rest of it's just going to be the algebra. The algebra is going to get tough. All right, so let's see here. We have 2x cubed minus 4x plus 1. Okay, so there's our graph. And then here's our line. It was 2x minus 3. There we go. All right, let me erase some stuff here. Okay, so here's the graph. Here's 1. Here's negative 1. So that is the point 1, negative 1. And you can see that our blue line, y equals 2x minus 3, comes through there, hits at that point, and appears to be tangent to the curve. Yes? Good. All right, so that went well. Let's try something else.
Does the graph later get intersected by that line?
Does the graph what?
Does the graph get intersected by that line down below?
Okay, so that's what I was saying earlier. When you have a circle, a tangent line can only hit the circle at one point, right? But when we're talking about tangent lines here, if we want the slope of the tangent line at this point, right, we're only wanting it to hit at one place here, locally. We don't care what happens over here, all right? We don't care. So it's okay that this line intersects our graph somewhere else. That's fine. That's where the idea of tangent is a little different than on a circle. Okay? All right, I actually want to do something a little bit different before I give you the next example. I want to do this. Let's go back to that same problem I just had. All right? 2x cubed minus 4x plus 1. And what I'm going to ask you is to find equation of tangent line at x equals 1. Now, what I'm saying by this is I want you to do the exact problem that you just did. All right, see how I worded this? Find the equation of tangent line at x equals 1. What I did not give you, when I worded it this way, what I did not give you is the y coordinate, right? I didn't give you 1, negative 1, did I? So that means you would have to understand that at 1, you would have to figure out what the value was at negative 1. Understand the difference between that? Okay, but I don't want you to just do it at x equals 1. I want you to do it at x equals 1, 3, negative 4, 7, 9, and let's just say negative, let's go 0. Okay, so let's appreciate how bad that would suck for us, okay? That would mean that we actually have to do this, what we just did, 1, 2, 3, 4, 5, 6 times, right? Yes? And that becomes very tedious. Wouldn't you agree? So maybe there's a more efficient way to do this. Maybe there's a more efficient way. If we come back to this, and we look at that formula, slope of the tangent line, this formula gives us the slope of the tangent line at x equals a, right? And what we did initially was we replaced the a with 1. But why don't we do this instead? Why don't we leave a in the formula as a variable and work through the algebra, and at the end, whatever our answer is, it should have a in it. And that should represent the slope of the tangent line. And then what I can do, is I can plug in the different values of a after I've done all the algebra, instead of having to plug in before and do the algebra separately for each 6 problems. Does that make sense? Now this is fundamentally important because this is what the next section's about, is that understanding that this right here, the slope of tangent line, actually generates a brand new function, and we call that function the derivative. So let's get to this though. So what I'm going to do is I'm going to say this is too much, right? This is too much. I don't want to do this work 6 times. So instead, I'm going to find the slope of the tangent line at x equals a first. Not at x is 1 or 3 or negative 4, at a. I'm going to leave it as a variable. So that means that the slope of the tangent line is limit h goes to 0, f of a plus h minus f of a all over h. And this time I'm not going to replace the a with anything. I'm just going to leave it as a plus h. And now when I do this, limit h goes to 0, when I do a plus h into my function, it's going to look like this. 2 a plus h cubed minus 4 times a, times a plus h plus 1. Okay, do you all agree that that is this piece right here? That's this. Right? Now, this is the part you have to be a little careful with. Minus, that's this minus, right? F of a. This is no longer a nice number. In the previous example, that was just negative 1, wasn't it? But this time, it's f of a, and I don't know what a is. So f of a is this function with a replaced for x. So isn't that going to be 3 terms? It's going to be 3 separate terms. It's going to be 2a cubed minus 4a plus 1. Now, what am I missing here? Because that's not correct. I need a parentheses. I must have parentheses here. And the reason is because you're subtracting f of a, right? And if you're subtracting f of a, you're subtracting the whole thing, which means if it has more than one term, that negative is going to have to distribute. That is probably the biggest mistake I see students make, is they forget to put this in parentheses, and then things just go off the rails from that point on. Any questions on why I did that? Okay, so this is this. And then we still have all of that divided by h. Now, because of time constraints, I'm going to do the a plus h cubed just mentally, and you can trust, I can trust that you could go and do all the multiplication for that. Yes? Okay. So this is limit h goes to 0, 2. Then if you cube that, you get a cubed plus 3a squared h plus 3ah squared plus h cubed. Okay, so just trust me that when you cube that, you get that. All right? All right, keep going. Distribute a negative 4 through. So negative 4a minus 4h plus 1. I'm going to run out of room here. And then I'm going to pass the minus sign through these. So minus 2a cubed plus 4a minus 1. All of this over h. Look how nice and neat my work is. I start out with the definition. Next line says equals. I wrote my limit. I wrote it all out again. And it says equals again, and then limit, and then I wrote it all out again. See how that is?
Don't all your students work?
That's most of the time. Yes, that's what it looks like. So you don't want to have like just scratch work. Like you don't want it to look like your work is just random ideas. Okay? It should be like writing a sentence or writing a paragraph. Periods in the right place, capitalization. This is the same thing in math. All right. I'm going to do something now. What am I going to do? Distribute that 2 through, right? So 2a cubed plus 6a squared h. So I did here, now this one, plus 6ah squared. Now this one, plus 2h cubed. minus 4a minus 4h plus 1 minus 2a cubed plus 4a, almost there, minus 1. All of this over h. This is your life right now. This is your reality that you're in right here. All right? This is the algebra you have to be able to do. And I'll be honest, this is a polynomial function. The algebra required to do this limit with the polynomial function is not that bad. I'm going to give you some harder functions, and you'll see the algebra can get messy. This is really, you just have to keep track of everything. You just be careful, all right? All right, here we go. Good things should happen. Let's see if they happen. 2a cubes are gone. I'm just going with what I see. Minus 4a plus 4a. Plus 1 minus 1. Anything else? I don't see anything else. I don't see anything else. And what you're really hoping for here, what you're really wanting to happen, is you're wanting to be able to cancel this h out. That's what you really want to achieve, is that h going away. Which means what you have left up top, hopefully each one of them has an h in it, which they do. All right? So let's see, on my next line, let's see if I can combine that together. I'm going to realize I need to pull an h out. And I'm hoping that's not too much to ask of you to realize that also. That I'm going to put these terms together, but I'm going to pull a factor in h out of each one of those. So is that all right? That's all over h. And that allows these h's to go away. And now, I'm going to take the limit on the next step. So here I'm doing limit. All I have is 6a squared plus 6ah plus 2h squared minus 4. There we go. Now at this point, if I let h go to 0, that means anything that has an h in it is going to go away, right? So that means this guy is going to vanish to 0, the whole thing. This is going to vanish to 0. And all I'm left with is 6a squared minus 4. This is the slope of the tangent line at x equals a. That's the slope of the tangent line. So notice something. I gave you 6 different values to use for a, didn't I? I've only computed the limit one time. And I have a formula now that gives me the slope of the tangent line. All you have to give me is the a. So what's the slope of the tangent line at 1? Well, you just plug 1 in for a, right? And you get 2, which is what we had earlier. What about at 3? What's the slope of the tangent line? So 3 squared is 9, right? Times 6, 54, minus 4, 50. At negative 4, we just replace that with negative 4. So these numbers are going to get kind of big. Negative 4 squared is 16 times 6, take away 4. That's the slope. How about at 0? Negative 4. Understand? Now, isn't that more efficient? I mean, the algebra was a little messy, but isn't that better than doing it 6 different times? Okay. So I'm not going to get the answers to all 6 of these. All right? Let's just do one of them. All right? Let's just do one. And let's do the 3. Okay? If I were going to do that, what would I need to do now in order to get the equation of the tangent line? Because all I have is its slope. So at 3, at x equals 3, what is the slope of the tangent line? Let's get that first. And that you use this formula, right? So 6 times 3 squared minus 4, that's 50. So that's the slope of my tangent line, right? But I also need the point on the graph, don't I? I actually need the x and y coordinate. So what is the point on the graph? Well, I know the x coordinate's 3, don't I? How do I get the y coordinate? Plug it into the original function, right? So Let's go ahead and plug that in. I'm just going to put f of 3. How about that? Like this? Because that's what I need to do, plug in 3 into the function. So let me work that out. What is f of 3 here? Is 2 times 3 cubed is 27, minus 4 times 3, and plus 1. So 27 times 2 is 54, minus 12 plus 1. So 54 minus 12, 42? 43? 43? 43? So this is the point 343. Y'all still with me? All right, I think I'm ready for the equation of the tangent line then. The equation of the tangent line, tan line at x equals 3 is y minus what? Y minus, what is it? 43 equals m, what's the slope of the tangent line? 50, then x minus 3 again. And then you could distribute, right? And then clean things up and move everything to one side and you'd have it. So we good? I'm going to stop here. So the point of this problem was to show you that the algebra we did was a little more complicated because you had a in there instead of the 1. But the result, that 6a squared minus 4, is much more powerful than having to do them individually, right? Okay. Let's do a completely new example now. All right, find the equation of tangent line to f of x equals square root of x plus 4 at x equals a. So this time I'm forcing you to do A instead of giving you a list. All right, let's get down to the slope of tangent line. So the slope of tangent line is going to be the limit as h goes to 0 of f of a plus h minus f of a over h. So that's hopefully burned into your brain by now. And I'm always reminded of, I don't know why I think of this, but how many of y'all have seen Kill Bill? Kill Bill, I don't know which one it is, 1 or 2, where she's training up in the mountains with that guy, with the crazy guy that can float in the air. Anyway, I don't know if you remember, all she does is trains all day. She just trains. And she's like waking up in the middle of the night, like punching, because she's still like, even when she's sleeping, she's still like training. So I want you to like be waking up in the middle of the night, like spieling off this limit, you know, like FA plus, man, what? Like waking yourself up. No? Is that too much to ask? Slope of tangent line. Limit. Okay, so that's burned into your brain. Now, I want to see what you do. Why don't you take a minute? I'm going to go get a drink of water. I'm going to let y'all see how you, like, write out that limit and then try and see if you can come up with what you need to do to make that limit work. Because you will have 0 over 0, but what algebra is going to be required? So take, let's see, it's 944, about. Let me see what y'all can do in 4 minutes. See if someone can come up with what you'll do. I know I said 4 minutes, but who could tell me what goes under this root? A plus H plus 4?
H plus 4, A of H in parentheses.
And then what about this one right here? A plus 4. This is what you should be working with right here. It's replacing the original function, replacing that with A plus H first, putting it here, and then minus, replacing this with just A. So is everybody's at that point? All right, let's see. Does anyone have an idea? I mean, right now, if you let H go to 0, the bottom 0, right? If that goes away, this is root A plus 4, right? This is root A plus 4, and you subtract, you get 0 over 0. So does anyone have an idea what we could do?
So we have to algebraically con it, right?
Something, yeah.
How about the conjugate?
Conjugate of that top part?
The top, the numerator.
Conjugate? Is it worth a shot? I think it's worth a shot. Right? Because conjugate has worked in the past when we've seen things like this. So that means you want me to come in here and multiply by 1, right? But the 1 that I'm going to use is going to be chosen carefully. It's going to be root A plus H plus 4, right? And then plus root A plus H. A plus 4, sorry. And then on the bottom, you have to do the same thing, right? Whatever you do on the top there, you have to do on the bottom. So do we all agree that that is a legitimate algebraic attack? I mean, whether or not it's going to work, we still don't know, right? But at least it's in our repertoire. Is that? No, that's not the right word. Is that the word? It's in our toolbox. We've got the weapon. Okay, so let's use it, see what happens. All right, now when we do the conjugate on top, we've done this before. We always need to realize that when we do the conjugate, the middle terms don't matter, right? It's really the first multiplication and the last multiplication that's going to really fall out of this. Just be careful on it because it is a little dangerous. So when I do this one times this one, that one matters. And they're identical. And they're both roots. So you're basically squaring a root, which means the root's going to go away. So all you're going to have is A plus H plus 4. Okay, the middle ones, I don't care. The last ones are those two. And again, I have the root and another root. They're identical, which is squaring it. So all I should get is A plus 4, right? However, this was negative and this was positive. So it's going to be minus the A plus 4. So it needs to be in parentheses, minus A plus 4. You with me? Now, on the bottom, you can start making your life really, really bad right now by trying to somehow multiply this H through here. Like you can multiply the H to here and the H to here. However, our goal is to make this H cancel because it's part of the problem of having 0 over 0. So instead, what you should do on the bottom is just leave the H out there and just put that conjugate in parentheses like this. So it's basically like you're not going to do anything to it. You're just going to leave it here next to the H. Right? Now, on the top, you are going to get some good things to happen, right? This A and then minus A is going to cancel. So that's going to cancel. And then this 4 minus 4. So all you're left with on top is H. And that's great. H over H. And then that conjugate. H's cancel, which will leave us with a 1 on top, right? So here's where I am. I have still remaining the limit as H goes to 0, and in the numerator I have 1. In the denominator I have root A plus H plus 4 plus root A plus 4. And what we're hoping for now is that when we take the limit that we do not get 0 over 0. And we're not going to get 0 on top, right? We're going to get a 1 on top. And on the bottom, if that H vanishes out, right? If that goes to 0, all you're left with is an A plus 4 under there, right? So you have root a plus 4 plus root a plus 4. Not times, right? Plus. So you have two things added together and they're identical. So you have two of them. So this is 2 root a plus 4. Make sense? So I took the limit, so I'm not writing limit anymore. This is it. This is the slope of the tangent line at A. All you have to do now is supply me with an A, and I will be able to tell you the slope of the tangent line. Right? Now, I said to find the equation of the tangent line at A. Let's just change that to slope, okay? Sorry. Because this is not the equation, right? Of the tangent line, it's just the slope. So somebody give me a point on that function. Any point you want, as long as it lives on the function. Someone give me a point. Try and make it a nice point. What's a nice point on that function? 5? Okay, if I plug in 5, I get 9. Root 9 is 3. So 5, 3 is on that graph, isn't it? And if I wanted to know the slope of the equation of the tangent line there. So what is the equation of the tangent line at this point 5, 3? Well, then I come to this formula here, right? But I need to know what the slope of the tangent line is there. So do we know the slope of the tangent line? We need the equation, but what's the slope of the tangent line there? So 1 over 2 root, then I'm plugging in 5 plus 4. So this is going to be 1 over 2 times 3. This is 1/6. The slope is 1/6. So that means the equation is y minus 3 equals 1/6 x minus 5. So I'm just using this formula here. I know the y coordinate, I know the x coordinate, and I know the slope of the tangent line. And I could do that for any point now. Someone giving me another point on that line, I can just keep on reusing this formula over and over and keep on spitting out. Yeah? So we needed the conjugate there, didn't we? Okay. Shall we do another one? Yes, we should. All right, let's try something completely different. And I'm going to leave this. Let's find just the slope. I'm hoping that you all understand that once you have the slope of the tangent line, the formula for it, getting the equation just requires that you find a point on the graph and then just use that point in here. Is that safe for me to assume that you're okay with that? Or yeah, you feel all right? All right, so how about for this next function, we try something kind of a little crazier. How about 2x minus 3 over x plus 5? A little rational function. Just for fun. I know how much you enjoy fun. All right, so the slope of the tangent line here is equal to the limit as h goes to 0 of f of a plus h minus f of a all over h. And we know we're headed for some rough algebra here. This is the limit. H goes to 0. Okay. What would f of a plus h look like? 2, then parentheses a plus h minus 3 over a plus h plus 5. Now, I don't necessarily need the a plus h in parentheses here because I didn't have, it was just x. So is that okay? That's just the top left portion. That is just the top left. What? H?
You had a plus x plus, never mind.
Yeah, I'm taking a plus h and I'm putting it here and here. Now I still need to do minus f of a. f of a, this part, is going to be what? 2a minus 3 over a plus 5. All of this, the entire thing, over h. I think I might clean up a little bit, but there's not much cleaning up I can do. I could distribute the 2 through here, right? That would be legitimate. Okay, so let me do that. 2a plus 2h minus 3 over a plus h plus 5 minus 2a minus 3 over a plus 5, the entire quantity over h. Now this is known as what we call complex fraction. Has nothing to do with complex numbers, okay? It's just a fraction that is complicated, complex, because it's fractions within fractions. So I'm not sure if anything here looks obvious to you. It probably doesn't. But kind of the rule of thumb when you get to something like this, like a complex fraction, is to try and get a common denominator between your two fractions up here. In other words, try and make these two fractions come together as one fraction. So you have to go back and remember, how do we add fractions? So if you have like 1/2 plus 3/5, if I wanted to add those, you would need a common denominator, right? So I would have to multiply, let's say, the top and bottom here by 5. I have to multiply the top and bottom here by 2. And then this would become 5/10 plus 6/10. And then you can put that together as 5 plus 6 over 10. So that's how we combine fractions together, right? We have to do the same thing here. But common denominator is a little more complicated. That, in numbers, it's easy. But with this, what would our common denominator be? Yeah, so let me show you first a mistake that people make. They say, look, I've got a plus 5 here, right? I've got a plus h plus 5, so all I'm missing over here is a plus h. So they somehow try and do like a plus h or plus a or something, and you can't do that. You cannot do that. You can multiply the top and bottom by something,